Where do you have the issue? So did you submit this assignment? Huh? No? Why not? Huh? Okay, එකක්වත් කරන්න බෑ. එකක්වත් බෑ. එච්චර මොකද? මොකක්ද අමාරු කියන්නේ? එකක් කියන්න බෑ. Okay, let me check if the waveforms given below are applied to an active high SR latch. Okay. Draw the resulting output waveforms in relation to the inputs. Assume the Q starts low, right? So active high SR latch, right? So latch means it has two inputs, right? S and R, right? And one output Q, right? So active high means what? S, R and output, right? So active high means if you make the set input high, output will get set. If you make the reset input high, output will get reset. Is that clear? Made it clear? Right? Okay, this you already know, right? Okay. Right. So these are the two inputs, right? So these are the two inputs we give to the S and R, and Q is initially low, right? So I'll start. So initially, that means let's say this is where it starts, right? So this is where T is 0. Okay. So Q initially is 0, right? Q is starts low, right? So at this point, what should happen? One more thing. So when both inputs are high and when both inputs are low, what will happen? Yes? SR latch. Active high SR latch. Check the note and tell me. One. So one case output is check. You have this in your note. So active high SR latch means something this one, right? Right. Right. This S and R. I forgot which one, which is that. O S O R. Which is S O R. Then you have the output Q and its complement, right? Q bar. Right? You have Q bar also. So when the inputs are 0, 0 or 1, 1, what's the output? Check the note and tell me. For 1, 1 case, is it 1? No, I don't think so. Wait, wait. Yes.
0.
0, is it?
Mm. 4.
No change කියලා එකක් කොහෙද තිබ්බ? lectures වල no change උයි undefined කියලා දෙකක් තිබ්බ මතකද? Can you remember? Can you see my screen now?
Yes, sir.
Okay, so this is the SR latch, right? Active high. This one. Can you see my screen? Right? So 0 means no change. 1 is actually undefined. So we don't use this 1 still. Okay. So
Okay.
0 means actually. Okay. 0 means no change. 1 means actually undefined. Okay. We don't use that still. So only these 3 states are we are using in with the active high HSR latch. Okay. So at this point, when T is 0, what should be the output? S and R both are what? Now you can tell. Huh? Sorry. Yeah, so there must be error, right? So actually we are not using this state. So let me check. Active high SR latch. Show the resulting output waveforms in relation to the inputs. Assume that Q starts low. Well, seems like there's error, right? Because both states are high means actually we are not using that. Okay. So active high SR latch. Let me check again. Yes, so there's error actually. You cannot do it. Okay, shall we check the next one? In this case also, they start with the high state. Yes, sir. How did this happen? But I didn't see that before. Okay. Right. Okay. Let's skip it for the moment. Okay. Seems like there's error. Number 2. It's a gated SR latch. So actually, I didn't cover this part, right? The gated SR latch. So I expect you to refer a little bit and find the answer. So did you find anything about the gated SR latch? Yes. Yes or no? Quickly, you have to speak. Yes.
Yes, sir, but can't understand that.
Okay.
Why
So
with the
okay, it's like this. So the gated SR latch is same as the normal XR, is same as this one, but the only thing is there's a enable button. Okay. So only when the enable button is high, you can change the output. Okay, it's like a gate. So when the enable input is low, there will be, I mean, whatever you do with SR and S and R, the output won't change. Okay. So let me explain it using an example. Let me copy this image. Okay. All right. Okay. Okay, let me take the most simple example. So let's say this is a active high SR latch. Okay. So we need to find the output Q. Okay. So let's say initially the Q is 0. Okay. So if it's a gated latch, then it has a gate, right? We call it the enable. En means enable. Okay. So let's say when t is 0, let's say t is 0, okay, t equals 0. Let's say the enable is low. Okay. Let's say S and R also. Let's say S is 1 in this case. And okay. Right. Okay, so can you tell me at this point what will be the Q, the output? Yes, yes, anyone? Uh, Actually, no, no, yes, 0. It will be 0. Why? Because you can see the enable is 0, right? So as long as the enable is 0, the output, you cannot change the output. Okay. As long as the enable is 0, output will be whatever you have before. Okay. Whatever the previous state will get applied to the next state. It won't change. Okay. Okay. So at this point, let's say enable becomes high, 1. Okay. So when the enable is high, actually it will work like a normal flip-flop. So let's say at this point, S becomes high. So now tell me what's the output? At this point, what will be the output? Yes, because set pin is now high, right? So the output will get set 1. Now let's say at this point, set becomes 0 again. So what will be the output at this point? So just after this point, what will happen? Can you tell me? Both are 0, right? Yes. Hmm? Yes. Yes, correct. No change. 0, 0 means no change, right? So the previous state will hold. And let's say at this point, R becomes 1. So what will be the output? Yes. The reset pin is high. 1. Yes, 0, right? Yeah, reset pin is high, right? So the output will get reset. Okay, so that's how the gated SR latch works. So I think now you can solve this, right? By yourself.
Okay.
Okay, right? Okay. So what's the next one? Number 3, difficult. නෑ නෑ එකට කියන්නේ මේ ෆ්ලිප් ෆ්ලොප්ස් දෙකට මේ ඉන්පුට්ස් දෙක වෙනම දෙන්න කියලා කියන්නේ. දුන්නාම අවුට්පුට් එක ගන්න. එතකොට මේ දෙකේ වෙනස මොකක්ද කියලා තේරෙනවා ෆ්ලිප් ෆ්ලොප්ස් එක. මේක මේක පොසිටිව් එජ් ට්‍රිගරින් මේක මේ බිඳුවක් දැම්මම නෙගටිව් එජ් ට්‍රිගරින්. ඕකේ. ඒතර මෙයාගේ අවුට්පුට් එක වෙනස් වෙන්නේ පොසිටිව් එජ් එකත් එක්ක. මෙතන මෙයාගේ නෙගටිව් එජ් ට්‍රිගරින්. පල්ලෙහාට යද්දි මෙතෙන් තමයි අවුට්පුට් එක වෙනස්. එච්චරයි මේ දෙන්නගේ වෙනස. right? අපි දැන් මේක ගමුකෝ නෙගටිව් එක න ะ. එතකොට මට කියන්න මෙතනදී the initially q0 right? initially 0 මෙතනදී මොකද වෙන්නේ? නෙගටිව් එජ් ට්‍රිගරින් නේ. මෙතනදී මොකද වෙන්නේ එතකොට? කියන්න බෑ. Hello? Can you hear me? Okay, so what happens at this point to the Q? Initially Q is 0, right? So what happens at this point for this flip-flop? Can you tell me? So the JK flip-flops, JK. So can you check the table? How they work? 1 0 0 1 0 0 and 1 1. Yes. නෑ වගෝ එකමයි. මේ ක්ලොක් එකේ වෙනස් වෙන තැන තමයි වෙනස්. ඒ කියන්නේ ක්ලොක් එකේ පොසිටිව් එකේදී තමයි අවුට්පුට් එක වෙනස් කරන්න පුළුවන්. අනික් එක්කෙනාගේ මේ සෝරි දැන් මෙයාගේ නෙගටිව් එජ් එකේදී තමයි අවුට්පුට් එක වෙනස් වෙන්නේ. අනිත් එක්කෙනාගේ පොසිටිව් එජ් එකේදී විතරයි ඒ කියන්නේ මේ පොයින්ට් එකේදී විතරයි අවුට්පුට් එක වෙනස් කරන්නේ. එච්චරයි. අනික ඔක්කොම එකයි. ඔන්න එක සිම්බල් එකක් දාන්න. දැන් නෙගටිව් එජ් එක නම් මෙහෙම පොඩි සිම්බල් එකක් දාන්න. මේක දැන් පල්ලෙහාට ක්ලොක් එක පල්ලෙහාට යද්දි තමයි වෙනස් වෙන්නේ කියන එක තමයි මම කියන්නේ. ටේබල් එක එකයි. කියන්න බලන්න ටේබල් එක මට. හ්ම්? මේකද කිව්වා. 0 මේක no change. මේක toggle. හරිද? හරි. ගන්න බලන්න අවුට්පුට් එක. Okay. So what happens in here? So this is a positive edge, right? Edge trigger, right? So the output will not change, right? It can change only at the negative edge trigger point. So at this point, what happens? J is high and K is low, right? J is 1, K is 0. J1, K0 means output will be high, right? Yeah, 1. So after that, nothing will change until it comes to this point, right? So at this point, what happens? J is 0, K is 1. So what will be the output?
0.
Yes, at this point it becomes 1. At this point, yeah, it becomes 0, right? Again, at the next negative edge, J is 1 and K is 0. So, right? So it will be again high. So likewise, right? So you can complete, right? Okay. So this is for a negative edge triggering flip-flop. For the positive one, the only difference is for the positive edge triggering one, output will be, let's say, initially 0 and it will change at this point, right? So at this point, positive edge, so J is high, K is 0, right? So the output will be high, right? 1. At the second positive edge trigger, J is 0, K is 1, right? So it will be at this point, like 0, right? Clear? So yes, okay, Tavish, drop on. आगे लिंक है हाँ right. What else? Number 4, Q output of an edge trigger D flip-flop is shown in the relation to the proximity. Then make a problem is number 4. Can you do it by yourself? Yes. Number 4 and 5 for D flip-flops. Yes.
Okay.
Okay. What about others? Moilu? Number 4, 5. You think you can manage it? Number 6, maybe, okay, I think I didn't explain about these two buttons, right? So, it's preset and clear bar. Okay, so, yeah, I didn't cover this. Okay, so you have to refer a bit and find how these two buttons work, right? So use the reference book. Actually, this example is from the reference book. This, I think, Floyd, Fluid, fluid. Okay. A digital electron. Okay. Actually, I forgot the name. Let me check. Exact name. Fluid. Hmm. Digital electronics or digital fundamentals. I forgot. Can you see my screen? Hello? Can you see? Hmm? Then hurry. Okay, Digital Fundamentals, 11th edition, Thomas L. Floyd. Okay, that's the book you have to, reference book you have to follow. Okay, Digital Fundamentals, 11th edition, Thomas L. Floyd. Okay. Okay, so we don't have much time left in the link. So can you try to answer the questions and let me know? For example, take this one, 15. Okay. So in question 15, right. So we have the diagram, sorry, the state diagram, right? So the state diagram should go like this, right? So how many states we have? 1, 2, 3, 4, 5, 6, 7, 8, right? Mm. To represent, let's say, 8 different states, how many digits do we need? We can use something like this, right? So actually it's given, right? So 8 different combinations, right? So how many D flip-flops do we need? Can you think of? Yes. Can someone tell me how many D flip-flops we need to represent these 8 states? If you take a D flip-flop, it can store a bit, right? 1 or 0, right? So if you take 3, Then these three guys can all store either a 1 or a 0, right? If you call them, let's say 1, 2, and 3, or let's say A, B, and C, then you can see 0, 0, 0, right? Outputs. These three have three outputs, right? So 0, 0, 1, right? 0, 1, 1, and so on, right? So with three D-type flip-flops, you can represent these 8 states, right? Okay. Then let's start from here. Let's say the present state is ABC 0, 0, 0, this one, right? Then okay, so we have a circuit, right? We are going to design a circuit. It has three D flip-flops, right? A, B, and C. Okay, no output, but it has input, right? Let's say X. When the X, so the input is, let's say, high, right? When X is high, it will go from 0, 0, 0 to next state. Let's say this is the present state, T. The next state, let's say T plus 1. It will go to the next state, 0, 0, 1 state, right? 0, 0, 1. Right? So when the present state is 0, 0, 1, right? This one. Okay, when X is 1, right? Okay. So it has just one option, right? When the present state is 0, 0, 1, let's say 0, 0, 1 case. When X is 1, it will go to what? From 0, 0, 1 to 0, 1, 1 case, right? 0, 1, 1 case. Okay. So likewise, you can complete this table, right? Then from the table, you can get the state equation, right? Maybe it's something like AT equals BT plus X or something, or BT times X or something, okay? Then from these equations, actually, you can draw the circuit, okay? So can you try to do that? Follow me. Actually, the answer is there in the book, in the reference book. I've given it. Right? We have just over 1 minute left. So, Mawidi, what do you think? Can you try again? Did you check the answer in the book? තේරුණා කියන්නේ දැන් මේක ස්ටේට්ස් 8ක් තියෙනවානේ. මේ ස්ටේට්ස් 8 කන්ටිනියස්ලි මාරු වෙවි යන එක තමයි වෙන්නේ, right? එතකොට හිතන්න දැන් අපි මෙතනින් පටන් ගමු. ස්ටේට්ස් තුනම 0 0 0 කේස් එක, right? එතකොට ඉන්පුට් එක අපිට මේකයි කියලා සර්කිට් එකේ. එතකොට next state එක වෙන්නේ මොකක්ද? 0 0 0 to 0 0 1, right? 0 0 1. එතකොට AT BT CT T කියන්නේ present state, right? ඒක 0 0 0 නම් X එක නම් next state එක 0 0 1 state.